When addressing the installation of power cables in raised floor environments, it's crucial to understand the National Electrical Code (NEC) requirements and their specific applicability to the situation at hand. In scenarios where raised floor exists but doesn't fully align with the stipulations outlined in NEC Section 645 concerning information technology equipment rooms, alternative interpretations and applications of the code come into play. The primary point of contention often revolves around whether the space beneath the raised floor is utilized as an environmental airspace or is simply regarded as a concealed space. NEC Section 645.5b directly addresses data processing areas where the floor is indeed employed as an environmental airspace. In such instances, the code mandates the use of data processing cables, often referred to as DP cables, for power supply wiring within the raised floor plenum. This requirement stems from the need to mitigate fire hazards and ensure that materials used in these spaces possess specific fire-resistant properties. However, if the raised floor isn't actively used as an environmental airspace for heating, ventilation, and air conditioning, then it's generally classified as a concealed space under the NEC. This distinction significantly alters the applicable code requirements. NEC Section 300.22c provides guidance on wiring methods within ducts, plenums, and other environmental airspaces, but also extends to other spaces used for environmental air. If the space isn't used for environmental air, we then consider the wiring methods for general wiring under Chapter 3. For concealed spaces that are not environmental airspaces, the NEC permits the use of non-DP power cables, offering more flexibility in wiring choices. However, this permission comes with crucial stipulations. Firstly, the cables must be installed and protected in strict accordance with their listing. This means adhering to the manufacturer's instructions and any relevant standards that govern the cable's intended use and installation. Secondly, the concealed space must remain accessible for maintenance and repair. This accessibility requirement is vital for ensuring that electrical systems can be inspected, repaired, and upgraded as needed throughout the lifespan of the installation. Now, turning to the specific scenario involving a 4-inch hole in the floor for cable passage and an outlet box mounted 2 feet below the floor surface, we can further analyze the code implications. The 4-inch hole can indeed be utilized to pass non-DP power cables through the concealed space, provided that the cables are adequately protected from physical damage at the point where they penetrate the floor. This protection may involve the use of bushings, grommets, or other appropriate fittings designed to safeguard the cables from abrasion or sharp edges. The outlet box mounted 2 feet below the floor offers a practical and accessible termination point for the cables. This arrangement allows for convenient connection of equipment and facilitates maintenance activities. It's important to ensure that the outlet box itself is securely mounted and properly grounded in accordance with the NEC requirements. An electrical inspector might express concerns regarding the accessibility of the outlet box located 2 feet below the floor. While the NEC doesn't explicitly mandate the use of flush floor boxes in concealed spaces, the inspector's concern about accessibility is valid. The intent of the code is to ensure that electrical components are readily accessible for inspection, maintenance, and repair. If the outlet box is deemed not easily accessible due to its location, the inspector may request modifications to improve accessibility. This could involve raising the outlet box closer to the floor surface or using a flush floor box that provides easier access. However, it's important to note that the NEC doesn't prescribe flush floor boxes as a mandatory requirement in this specific scenario. The decision to use flush floor boxes should be based on a balanced assessment of accessibility, practicality, and cost-effectiveness. Considering the NEC requirements and the specific characteristics of the raised floor as a concealed space, it's generally permissible to run non-DP power cables through a 4-inch hole in the floor to an outlet box mounted 2 feet below the top of the floor. The use of flush floor boxes isn't strictly mandated by the NEC in this situation, but accessibility considerations should be carefully evaluated to ensure compliance and facilitate future maintenance. Now let's delve into the specifics of how to approach this installation, keeping in mind the NEC guidelines and best practices for electrical work. Firstly, cable selection is paramount. Even though DP cables aren't strictly required in a non-environmental airspace, it's wise to choose cables that are suitable for the intended application and environment. Consider factors such as the voltage rating, amperage capacity, insulation type, and resistance to physical damage. Common cable types that might be suitable include type THHN, THWN, or XHHW conductors installed in conduit, or type NEC cable. Secondly, cable protection is crucial, especially where the cables pass through the 4-inch hole in the floor. Sharp edges or abrasive surfaces can damage the cable insulation, leading to electrical faults or safety hazards. To prevent this, use appropriate bushings, grommets, or cable clamps to protect the cables at the point of penetration. These fittings should be securely installed and made of durable materials that can withstand the wear and tear of regular use. Thirdly, conduit selection and installation are important. If you opt to use individual conductors like THHN or THWN, you'll need to install them within a conduit system. Choose a conduit type that is appropriate for the environment and the type of wiring being installed. Common conduit types include electrical metallic tubing, or IMT, rigid metal conduit, or RNC, and electrical non-metallic tubing, or ENT. Ensure that the conduit is properly supported and secured to prevent sagging or movement. All conduit connections should be made using approved fittings and methods. Fourthly, grounding is essential for electrical safety. Ensure that all metal components, including the outlet box, conduit, and equipment enclosures, are properly grounded in accordance with NEC Article 250. This helps to minimize the risk of electric shock and provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse. Use appropriately sized grounding conductors and make sure all connections are tight and secure. Fifthly, outlet box mounting and securing is important. The outlet box should be securely mounted to a stable surface and positioned in a way that allows for easy access to the wiring connections. Use appropriate mounting hardware and ensure that the box is properly aligned and leveled. Consider using a box extender if necessary to provide additional space for wiring. Sixthly, wire termination and connections are critical for reliable electrical performance. Use appropriately sized wire connectors and ensure that all connections are tight and secure. Follow the manufacturer's instructions for wire stripping and termination. Avoid over-tightening or under-tightening the connections, as this can lead to loose connections or damaged wires. Seventhly, labeling and identification will help with future maintenance. Clearly label all circuits and equipment to indicate their purpose and voltage. This will make it easier for future electricians or technicians to identify and troubleshoot electrical problems. Use permanent labels that are resistant to fading or wear. Eighthly, inspection and testing are essential before energizing the circuit. Once the installation is complete, thoroughly inspect all wiring and connections to ensure that they are properly installed and secure. Test the circuit to verify that it is functioning correctly and that there are no electrical faults. Use a multimeter or other testing equipment to measure voltage, current, and resistance. Ninthly, documentation and record keeping are important for future reference. Keep a record of all electrical work performed, including wiring diagrams, equipment specifications, and test results. This documentation will be helpful for future maintenance and troubleshooting. Store the documentation in a safe and accessible location. Tenthly, compliance with local codes and regulations is essential. In addition to the NEC, there may be local codes and regulations that apply to electrical installations in your area. Check with your local building department or electrical inspector to ensure that your installation complies with all applicable requirements. Failing to comply with local codes can result in fines or other penalties. In summary, when installing power cables and raised floors, it's crucial to understand the NEC requirements and apply them appropriately to the specific situation. If the raised floor is used as an environmental airspace, DP cables are required. If it's a concealed space, non-DP cables are permitted, but they must be properly installed and protected. Accessibility of electrical components is a key consideration, and the use of flush floor boxes may be recommended to improve accessibility. Always consult with a qualified electrician or electrical inspector to ensure that your installation complies with all applicable codes and regulations. Additionally, it's important to understand the different types of cables that may be used for power distribution in electrical systems. Each type of cable has its own unique characteristics and is designed for specific applications. Understanding the different cable types can help you choose the right cable for your project and ensure that it is installed safely and effectively. Type THHN, THWN, and XHHW conductors are commonly used for general-purpose wiring in residential, commercial, and industrial buildings. These conductors are insulated with a thermoplastic material and are available in a variety of sizes and colors. They are typically installed in conduit or other protective raceways. Type NEC cable consists of insulated conductors enclosed in a flexible metallic sheath. NEC cable is often used for branch circuits and feeders in commercial and industrial buildings. It is relatively easy to install and provides good protection against physical damage. Type NM cable, also known as Romex, is a non-metallic sheath cable that is commonly used for residential wiring. NM cable consists of insulated conductors enclosed in a plastic sheath. It is relatively inexpensive and easy to install, but it is not suitable for use in damp or wet locations. Type UF cable is an underground feeder cable that is designed for direct burial applications. UF cable is similar to NM cable, but it is constructed with a moisture-resistant jacket that allows it to be buried directly in the ground. Type SC cable is a service entrance cable that is used to connect the utility company's power lines to the building's electrical system. SC cable is typically installed on the exterior of the building and must be protected from physical damage. In addition to these common cable types, there are many other specialized cables that are designed for specific applications. For example, there are cables that are designed for high-temperature environments, corrosive environments, and hazardous locations. Choosing the right cable for your project is essential for ensuring that it is installed safely and effectively. Consider the following factors when selecting a cable type: the voltage and current requirements of the circuit, the environmental conditions where the cable will be installed, the potential for physical damage, and any applicable codes or regulations. Always consult with a qualified electrician or electrical inspector if you have any questions about cable selection or installation. Now let's discuss some additional considerations for raised floor installations. Firstly, static electricity is a concern in raised floor environments, especially in computer rooms and data centers. Static electricity can damage sensitive electronic equipment and disrupt operations. To minimize the risk of static electricity, use static dissipative flooring materials and grounding techniques. Secondly, fire suppression systems are often installed in raised floor environments to protect against fire damage. These systems typically use clean agent fire suppressants that are non-conductive and will not damage electronic equipment. Ensure that the fire suppression system is properly designed and maintained. Thirdly, cable management is essential in raised floor environments. Use cable trays, ladder racks, or other cable management systems to keep cables organized and prevent them from becoming tangled or damaged. Clearly label all cables to make it easier to identify and troubleshoot problems. Fourthly, access flooring systems are designed to provide easy access to the space beneath the floor for maintenance and repairs. Ensure that the access floor panels are properly installed and secured. Use appropriate lifting tools to remove the panels safely. Fifthly, lighting is important in raised floor environments. Provide adequate lighting to make it easier to work on electrical systems and equipment. Use energy-efficient lighting fixtures to reduce energy consumption. In addition to these considerations, it is important to follow all applicable safety procedures when working in raised floor environments. Wear appropriate personal protective equipment, such as safety glasses and gloves. Use lockout-tagout procedures to de-energize electrical circuits before working on them. Be aware of potential hazards, such as electrical shock, falls, and confined spaces. By following these guidelines, you can ensure that your electrical installations in raised floors are safe, reliable, and compliant with all applicable codes and regulations. Remember, electrical work can be dangerous, so always consult with a qualified electrician or electrical inspector if you have any questions or concerns.